look into limits at infinity. Yeah, the key word here is infinity. Now, I will take my time and explain to you, Sam. I want to explain to you the concepts, the idea of infinity. Now, I need you to know that infinity is a very large number that we cannot measure to be a particular number. Very, very large. Think of it as a very huge number. Very large, like very, very large. Like if I give you infinity amount of cash, you can never finish it for infinity number of years. Yes. Now, I am saying that infinity, written like this, like a sleeping eight sleeping. This is something we see as very large, very huge. Now think about this. A large number plus 2. What's the answer? A large number. Because 2 makes no difference. It will still be large. How about a large number, infinity, minus 200? The answer will still be large. I don't know if you're following. Infinity is too large. Okay, how about a large number, yes, plus a very large number? What's the answer? A large number. Yes. How about a very large number multiplied by, that is dot to show multiplication, multiplied by another large number? What do you think is the answer now? It becomes a large number. That's it. Alright. How about this? A large number minus a large number. Sam, I know you're taking a 0. It's not 0. This is indeterminate. Something we cannot determine. I know you think that anything minus itself is 0. Actually, even 3 minus 2 is not 0. These are large numbers. It is not necessarily the same number. It can be two different large numbers. That's why when we subtract them, we cannot say the answer. We cannot determine the answer. Call it indeterminate. Yes. Now, before I continue on this, I want us to explore further about infinity. Look at this. If 10 persons share 1 million naira, if 10 persons share 1 million amount of money, 1 million, let's say $1 million, $1 million, you will see that each person will get $100,000. Yes, each person $100,000. Now, what if these people now are no longer 10? What if there are 100 persons now sharing $1 million? What happens? What each of them will get their share will now reduce. If 100 share $1 million, their share, each person will go down. Yeah. I would like to share $1 million by 10 than by 100, because when they are 100, their share will reduce. Okay, what if there are 1,000 persons? 1,000 persons sharing the $1 million. What happens? Their share will reduce. Yes. Each person will not get $1,000. Each person. Yes. Now, if people sharing this dollar as they are increasing, their share will always be going down. If 1 million persons, now, yes, if 1 million persons should share $1 million, each person is going to get $1. Each person. Now think about this. What if 1 billion persons share it? What if 100 billion persons share it? What if 1 trillion persons share it? The share, as you see, went down from $100,000 to $1. It will keep going down. Now what if infinity persons to share it? Each person will have $0. What I'm saying is this: no matter any number infinity persons shares, they will receive 0 share. That's the power of infinity. What am I saying? In summary, I am saying that you have to know that a number divided by infinity must give you 0. Where k is just a number, where k is a real number. If k is a real number, divided by infinity is equal to 0. So we are saying that any number at all, two things by infinity should give us what? 0. 1,000 by infinity is 0. Any number at all by infinity must give us what? 0. The power of what? Infinity. Conversely, we know already that let's say we have a number divided by 0. If our limit is approaching 0, our answer goes to infinity. I am saying that if 0 is not a direct substitution, we take the limit where the input approaching 0, we have what? Infinity. This will still confuse you until you refer to our first video, where we treated the behavior of this function as s goes to 0. A number as s runs to 0 for this function, we'll observe that the behavior of this function is that the function goes to infinity. So we are summarizing this as when a number approaches 0, when we have a number by 0, we have infinity. Normally, a number over 0 is undefined. But we are saying that if it's a limit approaching 0, our answer is infinity. Yes. But what I want you to know is this. Whenever, take it or just note it down. Whenever you have a number divided by infinity amount of persons, your answer is 0. Let's still get more properties of this infinity. Let's see more powers of infinity. Just know that infinity is a very huge number. What do you think is going to be infinity divided by infinity? Two large numbers divided themselves. What's the answer? It's not 1. It is not 1. Yes, because they can be two different large numbers. Even 3/2 is not 1. Two different large numbers is not going to give you 1. So this is something we cannot determine. We call it indeterminate forms. Indeterminate. I don't remember the spelling. No, you are following, yes. Sam, my man. So that's it. We have various forms of indeterminate, things we cannot determine. For instance, infinity, power infinity, we cannot determine this. We can't. Infinity to the power of 0, we can't. All these things are things that we cannot determine their answers. You would think it's something you know, but it's not. It's not. 1 to the power of infinity, indeterminate. Yeah. Also, infinity to the power of infinity, something we cannot determine. Now, we have various forms of indeterminates in the app. Check out the Learn Extra app to see various forms of word indeterminate. Now, from the previous videos, I told you earlier that L'Hopital's rule is used to evaluate this form and also the form 0/0. These two forms only. Now, we shall not be applying L'Hopital's rule here. We'll simply just take some algebraic process in solving limits that tends to infinity. Before we solve some questions on these limits, yes, so far we've said stories about limits. I've given you the overview, the concept, the basic idea of limits. Now, I want you to take note of this special function. It involves the limit as s approaches infinity. Look at this. Let's all have a function, a special function. 1 plus 1/x, all to the power of x. If the limit of this function tends to infinity, what happens? I want you on your own to check out what happens. Go out here, place s as 10. Your answer, when you put s as 10, is 2 point something. Again, you put x as 50. Again, s as 100. Again, plug x as 1000. Be increasing. As you are increasing, it means you are approaching infinity. So you will see that at some point, the value of your x will be constant. It will stop changing. You have 2.718 thereabouts. And this number is a constant in mathematics known as E, named after Leonard Euler. Yes. So this E is a constant 2.718. This function is a special function for a limit where the input approaches infinity. At times in the exam, to confuse you, they may put here 3x. If here is 3x, what happens? the answer will have to also change. It becomes 1/3. Yeah. What if here is 5x? What happens? The answer will now change to become 1/5. Very simple. Sometimes in the exam, they will not change the denominator. They will go and alter the numerator. They make here to become 2, like this. What happens? The answer will also change. This time it becomes power of 2. So if the top changes, you have an exponent. If the down changes in coefficients, you alter the exponent to be a fraction. What if both up and down changes? For instance, 2/7x. It becomes 2/7. Yeah. We'll explain more of this in the app. Check the extra app for more explanations. I would have shown you this thing in the long form, but we don't have time for a long video for now. We'll update you for more explanation. So note that the basic idea of this unique function is that if I have the limit as n approaches infinity of 1 plus 1 upon n, all power of n, this is going to give me e, my unique function, special function that every person doing calculus should know. Now let's solve some questions involving rational functions. Let's solve this question. Limit as s approaches infinity of a fraction, a rational function, fraction. What do we do here? Simple. Before we come back to this question, before I come back here, I want to show you what I mean by degree of an expression. Degree. Keyword, degree. Look at this. If I have 2x cubed plus 5x squared plus 6x minus 1, A, B, and I have 4x squared minus 7x power 4 plus 3x plus 1. C, 7x minus 10. D, 8x. D, 5. Now from A to D, I have expressions. These are polynomial expressions. If you check our video on polynomial, you get more understanding on this. Now, what is the degree of each of these expressions? Sam, let's look into it. Now, the degree of each expression here is the highest power of x contained in the expression. For A, my highest power is, here is 1, invincible. And here is x power 0, which is 1. 1 times 1 is still 1. A constant, every constant contains x power 0. Now let's look at this. The highest power of x, in the expression is my degree. Therefore, here is degree 3 expression. How about here? In B, what is my degree? My degree is, here is 2, here is 4, here is 1, here is 0. What's the highest? 4. Therefore, I have degree 4 expression. For C, what's my degree? Here is 1, invincible. Here is 0. What's the highest? 1. Degree 1. D, what's my degree? I can't see the power of x, therefore I know that the power of x is 0, making D to become degree 0 expression, which are called constants. Now, once you know your degree, it's simple for you to evaluate the limit as s goes to infinity of every fraction. Yes, every fraction is in this form: g of x all over f of x. Now, if you have this fraction and the limit goes to infinity, what happens? Take notes. If degree of the one up and degree of the one down are equal, just like in this case, check up is degree 2, down is also degree 2. Are they equal? Yes. You don't have to even solve if it's OBJ, provided if the question is multiple choice and you confirm that the fraction, your limit is going to infinity compulsorily, and degree of numerator and the one down are equal. Your answer, without you solving, is going to be the coefficient of these powers that gave you your degree, which is 2 over 5. Without solving, that is your answer. If you're following, please hit the like button. Like this video to make us understand that you understood what we are doing. Sam, hit the like button. Now, let's take more examples on this. If I have limit as x runs to infinity of 2x plus 7 all over 4 all over let's say 7x minus 2. As x goes to infinity, you check the fraction. Numerator, what's my degree? 1. Yes. Here is degree 1, here also degree 1. Are they equal? Yes. Without solving, what's the answer? 2 over 7. That's it. But what if the degree of up are not equal? What if the degree of up and down are not equal? From the law of trichotomy, it's either that up is bigger or down is bigger in terms of degree. Yes. If I have this now, limit as x approaches infinity of 2x squared plus 5x plus 1 all over s cubed plus 10. In this case, degree of the one on top is 2. Yes. Obina, you're correct. Bisola, tell us, what is the degree of the one down? 3. Highest power of x is what? 3. Therefore, down is degree 3. What happens? Up and down is not equal. You can't say that the answer is 2 over 1. Whenever up and down is not equal, you check which one is bigger. If it's down, it means that as they are going towards infinity, the down one will reach a larger value of infinity. So whenever the one down is bigger, your answer is going to be 0. And whenever the one on top is bigger, your answer, whenever the degree on top is bigger, your answer is going to be infinity. I will show you the algebraic process for solving this, in case you have to solve in the exam as a theory question. Let's solve one of these and believe we have learned limits as the input runs to infinity of a fraction. How do we solve this as a theory question? You simply, actually, the first thing you do is you take the limits. Taking the limits. What happens? If I take my limits, this will be 2 into infinity squared plus 5 times infinity minus 3 all over 5 into infinity squared plus 4 times infinity minus 1. I will say that infinity is a very large number. Remember? Yes. Now what do you think is infinity squared? Infinity, a large number, times itself. It will give us a large number. Times 2 will have equal to, this will be giving us 2 times a large number is going to be very large. And we can't say very large, just say infinity. So plus infinity being a large number, a huge number, 5 times a huge number will give us a huge number, yes. So a huge number minus 3 will still be huge. So that's what happens here. This squared, huge. 5 times this, yes, still huge. Plus 4 times, yes, minus 1 is the same. So this will give us infinity over infinity, which is indeterminate. Indeterminate. So what can we do? We can actually take L'Hopital's rule here, differentiate the function one by one. But a more clever and short process, algebraically, we can do here is to divide all through the function by the highest power involved in the function. And this will be, let's see, divided through by s squared. I'm showing you an algebraic way for solving this as a theory question. Although we know the answer even without solving, because the degrees are equal and the answer is these numbers in their fronts. Yeah. So divide through by s squared over here becomes limits as s approaches infinity. Here will be 2x squared over s squared plus 5x over s squared minus 3 over s squared all over 5x squared all over s squared plus 4x over s squared minus 1 all over s squared. We divide everything by s squared. After this, you will observe that this will take out this, and this will take out this. We cannot simplify the rest. Which, if we simplify, it becomes limits as x approaches infinity. When we cancel x squared upon x squared, we have 2 plus x here is 1, x here is 2, have 5 upon x left, minus 3 over x squared, all over 5, plus, 1x is out, 1x down, have 4 over x, minus 1 over x squared. So if we take our limit again, taking the limit again, taking the limits again, what happens? If I take my limit this time, taking my limit again, I will have to go and plug all the x as infinity. And this will be 2 plus 5 over infinity minus 3 over infinity squared, all over 5 plus 4 over infinity minus 1 upon infinity squared. We have known the behavior of limit, that a number over infinity tends to 0. Yes, I'll explain this thing to you. If you are seeing a mountain, let's say you're driving and you see one big mountain. As you are driving away from this mountain, the height of that mountain will be getting smaller and smaller. There will be a distance you will drive, let's call it very far, like infinity. The height of that mountain will turn to 0. So we are saying that a number over infinity is 0. Distance squared, infinity squared means a large number times itself, a large number. So 3 over this is also 0. So all these places will give us 0, making us to have this to be equal to 2 plus 0 minus 0, all over 5 plus the number of infinity 0 minus the number of infinity 0, which is equal to 2 over 5. That's the way we solve it if it's theory in the exam. But for those who need multiple choice, just check your degree. Are they equal up and down? Yes. If it's equal, the numbers in their front gives us the answer. If the one under is bigger, assuming here now is, let's say, 5, degree under is bigger, what's our answer? Our answer must give us what? 0. What if the one on top is bigger? Let's say, for instance, here is 7. Our answer will now change. If the one on top is bigger in terms of degree, your answer is going to be infinity. Remember, any limit in which the answer is infinity, that limit does not exist. Take note. Any limit in which the answer is infinity, the limit actually does not exist, because we expect all limits to converge to a particular real value. So if the answer is not a real value, the limit does not exist.